For project 3, we chose lifting a heavy object. Chosen movement is lifting a heavy object from the floor similar to a deadlift. This is a compound movement involving the hip, knees, and spine. The primary mover are quadriceps, which extend the knee, the hamstring, and glute, which extend the hip and the forearm and finger flexor that maintain grips. Synergists like the abductor and calf helps stabilize and control leg movement, while the core stabilizer and the abdominal and oblique keeps the spine aligned and prevent back rounding. From a physical perspective, the hip and knee act as liver. By bending at the hip and knee, we shorten the liver arm between the low and the spine, which reduces torque on the lower back. This allows stronger leg and hip muscle to handle more of the force, improving efficiency and lowering injury risk.
The dominant ATP production pathway is the ATP PCR system, because the act of lifting a heavy object is a intense short duration activity rather than a continuous action. The connective fiber type requirement to do this action is the fast twitch glycolytic fiber, but if this was to happen repeatedly, it would be considered anaerobic glycolysis.
For IC coupling, when lifting a heavy object, our brain sends an action potential down a motor neuron that connects to the muscle fibers involved. The signal travels to the neuromuscular junction. When the signal reaches the end of the motor neuron, it releases ICH into the tiny gap between the neuron and the muscle. ICH binds to receptors on the muscle cell, causing deploration, meaning that the muscle fiber electrode charge changes, starting its own electrical signal. These T tubules signal the SR to release calcium ions into the cytoplasm of the muscle fiber. The increase in calcium allows isotin and myosin filaments to interact, starting the cross-bridge cycle that causes muscle contraction. The entire process happens in milliseconds and is tightly coordinated. As the brain sends repeated action potentials, calcium is continually released and reabsorbed, allowing for smooth, sustained contractions needed to lift and hold a heavy object. When the neural signal stops, calcium is pumped back into the SR, isotin and myosin detach, and the muscle relaxes.
Lifting a heavy object, muscle force is created through the sliding fragment mechanism. Calcium released from the skeleton plus reticular bone to trochion, undercurrent binding site on actin. Myosin head then attach, pull the actin inward, and use energy from ATP to shorten each skeleton. Thousands of these tiny contractions work together to produce movement and lift the weight. As long as calcium and ATP are available, this cross-bridge cycling continues. If the object is held still, the cross-bridge stay attached longer, creating an isometric contraction that quickly causes fatigue.
We chose poor grip on a heavy object. The muscles that are being overloaded is your forearm, hand muscles, your bicep, your brachioradialis, your shoulder, your back stabilizer, and your more specific muscles. The ATP PCR system would fail first. On a cellular level, the ATP would rapidly be consumed, dropping levels. ADP and AMP levels would rise. PCR would also be depleted. Calcium would be imbalanced. Those are just some of the examples. For correction and training strategies would be improve lifting technique, like lifting your legs, avoid twisting the object. Strength training, just gradually lift heavier things until your muscles can stand it. Don't prolong lift more than necessary. Allow for recovery, and if objects too heavy, do it to your person lift.